In this problem, we are combining three science concepts together. The first one is writing chemical formula from the given names. The second one, describing a chemical reaction in terms of chemical formula. And then from there, we are going to use a scenarios to solve for the unknown values. Here is a quick summary of writing formula for different type of substances. And here we have the ion charges for the periodic table, as well as a list of common polyatomic ions. So here is the scenarios. Magnesium oxide decomposes into magnesium and oxygen gas. How many liters of oxygen gas are produced when 47.9 grams of magnesium oxide completely decompose at STP? STP is standard temperature and pressure. So magnesium oxide is this. Magnesium is 2 plus because in group 2A. Oxide is in 6A, so it's 2 minus. Because the charge cancel each other out, so we have MgO. Decomposes into, we can think of this as a product sign represented by the arrows, into magnesium, which is an elemental metal, so we just have Mg. And what else is being decomposed into? Oxygen gas, which is an elemental gas, so it's going to be diatomic molecule O2. Now, is this chemical equation balanced? Let's check it out. We have MgO, MgO. In this case, we have 1 Mg, we have 1 O. Over here, 1 Mg, but we have 2 oxygen. So, of course, we're going to balance the oxygen. We're going to ask ourselves, here we have 1 oxygen, we have 2 oxygen. We look back here, look for the oxygen. The subscript is 1, so 1 times what coefficient will give us 2? The answer is 2. 2 times 1 give us 2, but that will affect the magnesium as well. 2 times 1 give us 2. So now the magnesium is not balanced, so we have to balance it out. So in this case, we have magnesium 1 and we have 2 over here. So 1 times what coefficient will give us 2? In this case, 2, so we have 2 Mg. And finally, we have a balanced chemical equation describe the decomposition of magnesium oxide. But we are going to express in terms of mole. So we have 2 moles of magnesium oxide decomposed into 2 moles of magnesium and 1 moles of oxygen. Let's continue. The second part asks us, how many liters of oxygen gas are produced when 47.9 grams of magnesium oxide completely decomposed at STP? So your given could be, in this case, 47.9 grams of MgO. And we are looking for, what is it? We are looking for the liters of oxygen. So we have liter of oxygen gas, O2. This information tells you that you have to solve this problem using stoichiometry flowchart. So we are going to get over there right now. So let's go back, and we have our given as 47.9 grams of MgO, magnesium oxide, and we are looking for liters of oxygen gas. To start, we first notice there are 2 different chemicals. So our given chemical is always chemical A, and our unknown chemical will always be chemical B if they are 2 different chemicals. So here we have grams of A, which is right here. This is where we start. And we are looking for liters of B, which is right here. So to get from here to there, we have to go down, across, and going down with 3 different conversion factors. So we have to multiply by 3 different conversion factors. So how do we use the flowchart based on the 3 conversion factors? With that information, we are going back to our given again, 47.9 grams of magnesium oxide, and we time all the conversion factor in the correct order. So the first conversion factor is 1 mole of A equal to the number grams of A. Notice how I copy exactly from the flowchart, and we follow by the next one. We have number of mole A equal to the number of mole B. And lastly, we have the last conversion factors. We have 1 mole of B equal to 22.4 liters of B. The next step is to plug in the variables. What is chemical A in this case? It is MgO. So MgO for all the letter A. And then here you go, we have one MgO over here as well. And then for the chemical B is O2, so it's O2 right there, O2 right there, and O2 right there. Here we look at this first conversion factor. It has a number, so we don't worry about it anymore. But right here, it doesn't give you a number, so we had to find the molar mass for MgO, or magnesium oxide. So based on the periodic table, the mass for Mg is 24.31, and oxygen is 16.00. So what we have here is 1, 3, 10, 1, so it's 40.31 grams. So that gives us 41.31 grams of magnesium oxide. So we are done with that part of the conversion factor. We move on to the next one. How do we get the number for the number of moles for both magnesium oxide and oxygen? Is that we go back up here and we look at this. It's a coefficient. So we go back to the other one and look at the coefficient for MgO, or magnesium oxide, is 2, and for oxygen is 1. So we have, right here would be 2, and oxygen again is 1, based on the balance equation that we just solved before. And we're done with this conversion factor. And we move on to the next conversion factor. This one's pretty easy, because the number is given to us, and then we have nothing left to do for that conversion factor. So here we have our flow chart. Let's use the flow chart to solve the problems. Start with our given 47.9 grams of MgO, and we multiply one conversion factor at a time. This is our first one. Here we have grams of MgO. Of course, we need to cancel this out, so we're going to look at the side that has gram of MgO is 41.31 grams of MgO. If this part is on the bottom, the other part has to be on top. So we have 1 mole of MgO on top. That conversion factor is done. Now we move on to the next conversion factor. Here we have moles of magnesium oxide, so we need to cancel that out. We look at this conversion factors right here. In this case, we have 2 moles of magnesium oxide, so that part is going to be on the bottom. And of course, the leftover part will be on top, 1 mole of O2. And we are done with that conversion factor, so we move on to the next one. Here we have moles of oxygen, so of course, this part will be on the bottom. We have 1 mole of oxygen, and the other part will be on top, which is 22.4 liter of oxygen. We come back, we cancel the chemicals and the unit. Gram of magnesium oxide cancel out, mole of magnesium oxide cancel out, mole of oxygen cancel out, and give us all liters of oxygen that we are looking for. To plug this in your calculator, we just multiply everything on the top, 47.9 times 1 again, and times 22.4, and the unit will be liter of oxygen. And then we divide everything on the bottom, which is 41.31 times 2 times 1. And this would be our final answer.